Hello and welcome to this video, and this is a question of series, and I just wanted to explain you how to do this question. And this is a series which start to fastly you are okay. So now we start with finding the UR, okay, and after that we are supposed to find the lambda value and the fr value using this, and after that we have to find the sum, and we have to show this is a convergent series, and now when we have to make it find the value of this. So this is our question. So this is actually a 12 minutes question, and we will start to do the question. First, when you want us to find UR, I have to observe what is going through the sequence. So if I take this number, okay, I will start to write on with UR, okay. So UR equals, right, see these numbers 1 1 1, so it's going to continue with 1, so it's going to be 1 over, right, this is 5 7 9. If you take 5 7 and 9, 5 7 9, so you end up with, you get a arithmetical progression with common ratio 2, so it's going to be 2r plus, so if you put 1 here, 2 into 1, it's going to be 2, so you have to add a 3, so it's going to be 2r plus 3 into, you find the similar one here, 7 9 11, you find the similar thing, so again it's 2r plus, but it's going to be 5, so this is going to be our UR. So using this UR, now we have found this, and we'll go on for finding to the lambda and FR, and I'm going to use write this UR again, and after that I'm going to make it what is going to happen with this. So this UR equals 1 over lambda into F R plus 1 over FR minus FR plus 2 over FR plus 1. This is what they have given. So what I'm going to do is, I'm going to just observe it, that FR and FR plus 1, if you multiply this, this is going to be the denominator. So denominator UR, I will replace the UR, that is 1 over 2r plus 3 into 2r plus 5 equals 1 over lambda into, it's going to be FR into FR plus 1, and this is going to be FR plus 1 all thing squared minus FR into FR plus 2. So what I can observe is, okay, this particular FR and 2r plus 3 has to be the same, and these 2r plus 5 and FR plus 1 has to be the same. So I can conclude that it has to be FR and this has to be FR plus 1. If you replace R plus 1 here, you will get 2R plus 5. Therefore, you conclude with FR equals 2R plus 3. Right. Now it's all over with this. Right. Now what I'm going to do is I'm going to put it here, and simplify it off. So this is equal to 1 over lambda into fr plus 1 squared. Fr plus 1 is 2r plus y, 2r plus y, 5 all things squared minus 2r plus 3 into 2r plus 5, 2r plus 7, because it's r plus 3, r plus 7. Why this is r plus 7? Because it's r plus 2. So if you replace r plus 2 here, you get 2r plus 4. 4 plus 3 is 7. So 2r plus 7 over. And you get fr into fr plus 1. That's, I don't want to simplify it. 2r plus 3 into 2r plus 5. So this is equal to 1 over 2r plus 3 into 2r plus 5. So ultimately what happens? This gets cancelled out and this gets cancelled out. Okay, so I have to close the bracket, right? And so cross multiply the lambda here. Okay, so it's going to be like this: lambda equals 2r plus 5 all things squared is 4r squared plus 5 into 10 20r plus 25 minus 4r squared again, right? 3 into 2r is 6r. Okay, 7 into 2r is going to be 14, so 14 plus 16 is 20 r minus 21. So what happens ultimately? 4r squared gone, 20r gone, so you end up with 25 minus 21, where lambda equals 4. Right, so finally we have done this part. So now we'll go on for the next part. Okay, now we have to find sigma. So it's going to be, sigma is going to be easy, because sigma you have found, you have proved this is equal to this, ur is equal to this. So ur, I'm going to write it again, that is equal to 1 over lambda. So I'm going to write 4ur into fr plus 1. So it's going to be fr plus 1. So fr plus 1, okay, over fr minus fr plus 2 over fr plus 1. Right, it's a little bit difficult now writing this, okay, no problem. So what I'm going to do is I'm going to substitute from here. Similarly, I'm going to start with r is equal to 1. So it's going to be 4u1 equals f2 over f1 minus f3 over f2. Then r is equal to 2, so it's going to be 4u2 equals f3 over f2 minus f4 over f2, and r is equal to 3. So I can come for a conclusion now. 4u3 equals, so f4 over f3 minus f5 over f2. Right, so what I'm going to do is I'm going to continue this work throughout the space, and I'm going to finally put r is equal to n. So that is going to be 4 un equals fn plus 1 over fn minus fn plus 2 over fn plus 1, because I'm observing here this part and this part gone, this part and this part gone, so it's going to get an order and it's going to be cancelled out. So I'm going to sum this off. So when I'm summing this off, it's going to be 4 into, take it common, u1 plus u2 plus, this goes into un. At this side, what you get it here, you get f2 over f1 f1 minus fn plus 2 over, you get fn plus 1. Right, so now we will get it off and we will see what is happening here. This is going to be very easy. Now this part 4 into this entire thing you can write in sigma, so sigma r equals 1 to n ur equals fr, you know what is that, fr is equal to 2r plus 3. I think you have found it in this part. So 2r plus 3 fr equals 2r plus 3. Right, you substitute here, you put 2 here, 2 into 2, 4, 4 plus 3 is 7. Right, 7. You put 1 here because it's 1 here, so 1, 2 plus 3 is 5. Okay, you end up with this minus, this is n plus 2, so that is 2n plus 2, 2n plus 7. 2n, we'll make it sure again, 2n plus 2, 2n plus 4, 4 plus 3 is 7, so 2n plus 7. Okay, over 2n plus 5. Right, but when I go to the answer, I get 1 over 2 into 2n plus 5, so they're going to simplify this. So it's easy to simplify this because you can write 2n plus 7 as 2n plus 5 plus 2. So it's going to be, this is equal to 7 over 5 minus 2n plus 5 over 2n plus 5 minus 2 over 2n plus 5. So this value, okay, is equal to 1. Okay, so 7 over 5 minus 1 is going to be equal to 2 over 5. So this is going to be equal to 2 over 5. Take this 4 here down, this one, minus 2 into 4 into 2n plus 5. This is going to be equal to sigma r equals 1 to n ur. Right, so now cancel this, you get 2 times, cancel this, you get 2 times, so you end up with the answer, which is equal to 1 over 10 minus 1 over 2n plus 5. Careful, you have a 2 outside. Let me extend this line. This is minus. Okay, right. Now it's still done. So that part is shown. Okay, we have the answer. Right, now we can go on for the question again. Now you have to show this is a convergence series. What is a convergence series? Is when you go towards the infinity, you must have a value. So first I will find the value because we have the value. Okay, it's a convergence series. So what I'm going to do is limit n approaching towards infinity, right, sigma r equals 1 to n ur equals because I'm going to use the limit, it's going to be limit n approaches to infinity. Using the theory, I can separate this 1 over 10 minus limit n approaching towards infinity 1 over 2 into 2n plus 5. So when you put infinity here, okay, when you hit infinity here, this is going to be equal to 1 over infinity, that is going to approach towards 0. So if n approaches infinity, 1 over 2 into 2n plus 5 is going to approach towards 0, right? Therefore sigma r equals 1 to n when u r is going to be equal to 1 over 10. Therefore sigma r equals 1 to n u r. Sorry. Right. Okay. Is going to be right. Okay. Is equal to 1 over 10. Therefore it's convergent. Okay, so that's the end of this video, and thanks for a lot. And if you would like to subscribe us, and you can follow me on my websites. Okay, so my website will be www.mathscience.webs.com. Right, you can follow me www.mathscience.webs.com. So thank you for watching. Cheers.